Hello all, today we are going to discuss the problem prime and diagonal. So you are given 0 indexed two-dimensional integer array nums. Return the largest prime number that lies on at least one of the diagonals of the nums. In case no prime is present on any of the diagonals, return 0. So they are given some condition for how prime is nothing but which have two possible condition, that is it is divided by itself or one. And we have to check in two diagonals, that is both in the primary diagonals and the secondary diagonals. We have to check whether the prime number we have to return the largest prime number present in the diagonal. So let us first see the example. So you can see this 159 are said to be primary diagonals, and secondary diagonals are 357. So when you compare, first let us see how we can iterate through this. When you see this one, we can see the row value is 0 0. When you see the value 5, the row value and the column value is 1 1. When you see the value 9, and the row value and the column value is 2 2, we can infer from that the row and column value are same. So formula for finding the primary diagonal is nothing but I equal to I. When you come to secondary diagonal, the formula for finding it is n minus I minus 1. N is nothing but the whole length of whole size of the matrix, that is that is the row size. And 3 5 7 or secondary diagonals. So like we can see how this is coming. So the total number of columns present in it, sorry, the total number of rows present in is 3 minus the I value is, consider this as I, so the I value is 0 minus 1, which is equal to 2. So this we achieved this index. So through this formula we can achieve this index. So now let us see how we can so through this we can iterate through these formulas, we can iterate through these elements. But how to find the largest prime number? It is also simple. Like when you're iterating through this, check whether each element is a prime or not. After checking it, store it in some max variable and compare it with the and go to the next element, and check whether the current element is greater than the element that is being previously stored, right? So if I code it, you could get it. But you can see from primary diagonal which one is the largest prime. 5 is the largest prime, but after iterating to the secondary diagonal, we could conclude that 7 is the largest diagonal. So this is how we are gonna solve the problem. And just let me start coding it. Let us just declare some max prime variable, and initially we can initialize to 0. We have to start iterating through it. So we are going to declare some function called check prime, and in this we are going to pass. First, we have to check the primary diagonal. So for that, we have formula where I row and column is equal. So if it is true, we are gonna update. the max prime variable to. After going through the primary timer, we have to go through the secondary timer. Next, we are going to update. So after doing all, we are going to return it. So first, just let's define the check prime public boolean. We know how to solve. We know how to code a prime number. So I'm going to do with some optimized way, that is checking till the square number. So we are going to declare one count variable. If the count is equal to 2, the number is prime, or else it is not. So let us just start checking it. So I think I hope I done everything fine. Let us just run the code. Yes, it just got accepted. So just let us just submit it. Okay, got submitted. I hope you find this video useful. Thank you.